Hey, good morning, sixth graders. Happy Wednesday. So we're going to go through the last half of lesson 14. This is graphing, and it can be tricky. So I need you to rewatch this video as many times as you need to let it sink in, because this is tough. So we're going to talk about the infinite. So most inequalities have an infinite number of solutions. This means it is not possible to show all of the solutions in a list. However, it is possible to show all the solutions in a graph on a number line. Think about that for a second. Infinite literally means there is no end to the answer. So when we say anything greater than 3, we mean literally all of the things greater than 3. And in science, when we're talking about atoms and parts per million, and we start talking about pressure, and we talk about bacteria, we're talking about numbers that are so big that your brain can't even think about it. And we use a special notation that you'll learn in higher levels, but you just need to know that this is relevant information, and you have to start somewhere, and here's where we're going to start. So a solution set of an inequality is a set of all of its solutions. The graph of a solution set of an inequality is often a ray. Remember, a ray starts at one place and expands one way. So when the graph is, when you graph the ray, you graph an open dot if the endpoint is not a solution. So when I graph, so take a look at this. See how this has an open dot right here? This means that x is greater than 3. It's anything that is greater than 3, not including 3. It is not equal to 3. So if you go back up here and you look at where we were talking about, well, can it be greater than? Can it be, like we talked here, anything above 13 will work. But that does it include 13? Yes, because it shows this greater than or equal to. Okay, so let's go back down. Okay, so when the dot is open, it does not include that number. You can go both ways, obviously. So example 1 shows anything greater than, and example 2 shows anything less than. And again, it's this going this way. Okay. So graph all of the solutions of the inequality. So m is greater than 7. So it would literally be anything that is greater than 7. So we're going to open dot this way and graph this way. And this arrow means that it goes on for forever. If I draw an arrow, it means infinity. Anything that is less than t, or t is less than anything that is less than 5. So it does not include 5. It is less than 5. Okay, so just like that. Okay. So a shipping company charges an extra fee for boxes that weigh more than 200 pounds. Let W represent the weight. Remember, W is the variable. Variable is something that we don't know. It's a number that represents an unknown and can change, right? So let W represent the weight in pounds of box for which an extra fee was charged. Write an inequality for the possible values of W. Okay. So W is not equal to, right? It's more than, so hold on. The extra fee for boxes that weigh more than, let W represent the weight in pounds of box for which an extra fee was charged. Okay, so anything that is greater than 200, sorry, I did that backwards. So W has to be less than 200, right? Oh man, I think maybe I'm getting this confused. Hold on. So sometimes that happens and we just have to go back and reread it, right? Just for extra fee for boxes that weigh more than 200 pounds. So yeah, boxes. This is the weight of the boxes. They have to be more than 200 pounds, not including 200. That's where the fees are, right? Because it's asking for which an extra fee was charged. Okay, so we go back down here to our graph and we just say anything that is greater than 200 and we draw our arrow. That's all of the boxes that are going to be assessed fees. Okay, moving on. So anytime we color in the dot, instead of leaving it open, we'll color in the dot, and that means that it does include that number. So for example, here we are coloring in the 3 and drawing an arrow this way, right? Because our equation shows us that x is greater than or equal to 3. Same thing over here, except for going the other way. X is less than or equal to 6. So we're going to look at our 6. We're going to color it in, and we're going to move this way, right? Okay. Good. So graph all of the solutions for the inequality. So we're going to do m is greater than or equal to 7. It can be equal to 7, so we can go ahead and color that in. And it's everything that is greater than 7, right? So it goes this way. M is a number that is larger than 7, so we're going up. Okay. Moving on. 28. T is less than or equal to 5. So I'm going to find 5. I'm going to color that in because it can be equal to that. And it's going to go less than, right? It's all of the numbers that are less than 5. It literally goes down all the way below. It can even go below 0. It can go to negative 1.4 million. That's totally fine. It's a number that is less than 5, right? Okay. Oops, I didn't mean to get rid of the whole arrow, but here we go. Okay. So the weather reporter said temperatures would not rise above 3 degrees Fahrenheit all week. Let T represent the temperatures in degrees Fahrenheit for the week. Write an inequality to represent the possible values of T. So they won't fall below, they won't rise above. Let's highlight that part. The temperatures will not rise above 3 degrees Fahrenheit all week. So the number has to be less than 3. It can be 3 or less than, including, so we have to color this in just like that. Okay, and then our equation would obviously be T is anything less than or equal to 3. Okay, describe a real-world situation that can be represented with an inequality. Write an inequality to represent the situation, and then graph it on a number line. This one can be tricky, and I'll leave it to you to do whatever you want to do here. I'm going to write this in purple. Maybe I am. Okay. Let's see. Mr. Babinski says he needs a break and to come back anytime after 5 minutes. So that could literally be 100 minutes, it could be 6 minutes, it could be 5 minutes and 2 seconds, but it's got to be greater than 5, right? And the way that we would graph this, 0, 1, 2, 3, 4, 5. We would do color it in and draw an arrow going that way. And that's it. That is the rest of the unit. That's the rest of the lesson. Please finish your homework, and then tomorrow, Thursday, we will start lesson 15. Talk to you guys later.